Great. So welcome you all to the event today about data analysis and machine learning in competitive data science. And this event is organized by Google Developer Student Club at TU Munich in collaboration with the Student Club at ETH Zurich and University of Bologna, and also TUM AI. So really great to have you all here, joining from different clubs. And today we are really honored to have Luca Massaron with us. And he is a Google developer expert in machine learning, and have recently just published a new book about Kaggle, which he will talk about it more in depth later. And a small spoiler, should I mention it already, Luca? About
I think so. So everyone will be reading.
Yeah, so we will have some small quizzes prepared for you on Slido at the end of the talk. And the winner of the quiz will get an ebook copy of Luca's Kaggle book. So I'm really looking forward to that. And also, if you have any questions in between, feel free to post it on Slido. I will share the link in the chat in a second. And then we will have a Q&A session at the end. Yeah, so now without further ado, I will hand over to you, Luca.
Thank you, Danda. So I will first of all share my screen. And here is my presentation. So basically, Yanda already introduced me, but I can say a few more words to tell you that I work as a data scientist, and at the moment I'm working in finance in a high-tech banking group. So basically, we are dealing with financing and distressed corporate loans. I am an author because up to now I wrote over 10 books on data science, machine learning, deep learning, and AI. I'm a GDA, and especially connected with this intervention, I'm a frequent competitor on the Kaggle platform. I started already 11 years ago competing. I reached being a Grandmaster in discussion and a double master in competitions and notebooks. And at a certain point, I participated so intensively to Kaggle that I reached number 7th in the worldwide ranking in competitions. So you can imagine I spent really a lot of time on Kaggle. And that's the reason why at this point I decided to join with other interest in writing and prepare a Kaggle book, a book containing a lot of tips and tricks for being a good player of Kaggle, and also taking the best out of Kaggle, which doesn't necessarily mean scoring high in a competition. So it's recently published. It is over 500 pages of code and tricks. And we are going to offer one ebook to be drawn among the respondents of a Slido questionnaire at the end of the intervention. Basically, it's about the contents of the slides, so just pay attention. Questions are not too difficult, but some may be a little bit tricky. So time to start. I prepared quite a lot of slides, so I will try to cover them all. And basically, the idea is first to start providing some historical references, because when we talk about Kaggle and competitive data science, it's often, quite often I find that even, good players do not relate to the background of such competitions. So we are missing something, and it's important just to point that out. And then we'll delve more into Kaggle. I don't know if everyone among you already know about the platform, what it's about. So I will give a very quick introduction, and I will discuss some of the key aspects of Kaggle and competitive data science. And finally, I will just show to you what the flavor of competition is, just taking one random competition, one of the latest I participated to, and just pointing out what interesting I could find in such competition, because it's amazing that every time, no matter how long you have been on Kaggle, you always can find something interesting in any competition you take. At the end, I will, of course, answer to all your questions. So let's start immediately with some history. So roots of Kaggle and competitive data science is actually in competitive programming. Competitive programming has a long history. It dates back to the 70s, and the first example is the International Collegiate Programming Contest. It's a contest where representatives of universities, they find all together to solve a set of problems by collaboration between themselves, these small teams of about 3 people. And actually, when it started, the ICPC, it had become immediately a very successful format at that time, because the experience of participating in the competition gave the opportunity to be in the spotlight, to be recognized if you score high, or even if you won a competition, and especially to get under the eyes of recruiting companies. So it offered interesting professional opportunities to the participants. You can see an example, a visual configuration of one competition, a lot of people all gathering together and all struggling to solve some problems. And actually, apart, the few ones won, participating has been for many a very formative experience. And a few of the finalists become quite renowned. We have Adam Angelo, who was the CTO of Facebook and the founder of Quora, for instance. Nikolai Durov, the co-founder of Telegram, the messenger application, and Matei Zaharia, the creator of Apache Spark. So actually, it has been a quite interesting forging place, and it gave inspiration to the flourishing of various competitions, especially after the year 2000. Why? Because of the internet, remote participation became more feasible, allowing international competition to be run more easily and at lower cost. And basically, the format for all programming competitions is very similar. You have a series of problems, and you have to code something in order to solve them. The winners are given a prize, but also a good collateral prize is being spotted by recruiting companies or simply becoming very famous among your peers. And at the link I provide to you, you can find quite a lot of examples of such competitions. But what is important for us is that the format from coding could be easily replicated, coding and problem solving could be easily replicated to data science. And immediately, data science follow it. We have a KDD Cup, which is a very famous competition, apart from being connected to the conference, KDD conference, which has been held since 1997, and it is taken as an example of, a primordial kind of Kaggle. Participants were given a data analysis problem, usually to fit a model to a problem, and it has become not only a source of interesting papers and solutions, but also a model for quite many others competitions. And here I have to quote, because KDD Cup is quite academic, also on the government side, all the DARPA challenges that involve problems in self-driving cars, robotic operation, machine translation, many improvements in machine translation came from the DARPA challenges. Speaker identification, fingerprint recognition. Clearly, DARPA was financed by the USA government, had some military purpose in the end, but all the competition were public and quite interesting. And on the business side, which we'll discuss more about it later, we can quote the company Netflix that entrusted, the outcome of a competition a few years ago to improve its algorithm for predicting user movie selection. That is, they basically made a competition on how to make the recommender system for movies much better. And about the Netflix competition, it's often taken as an example of how a competition should be made, and also how a competition could actually derail because it could have unexpected consequences in respect of what the sponsor expected. So I mentioned that the Netflix competition was based on the idea that by putting people competing, they could find a better way to create what is called a collaborative filtering. That is a way to figure out what movies could be better to suggest given a previous user history preference or vision of movies. So this is a competition that has been held a few years ago, and it had a grand prize of $1 million. And it had a very specific bar because everyone had to at least improve their existing algorithm, the Cinematch. Actually, they did. And the competition ran for quite a few years, not just, a spot competition of a few months. It ran from 2006 to 2009. And so victory for teams made up of a fusion of many other teams. Why? Because immediately it came up that a very good strategy was to use singular value decomposition. And singular value decomposition required, different approaches based on approximation, given the large number of users and movies involved in the metrics, the reducing metrics. So we found out that not only singular value decomposition and several tricks worked very well in that competition, but ensembling, that is averaging together, we use the term at the time blending together a competition made, the scoring higher and higher. So all the teams composed, and in the end, a team from Commendo Research Consulting by Tosher and Zara to actually later on Kaggle competitors, quite renowned Kaggle competitors, 2 researchers from AT&T Labs and 2 other researchers from Yahoo who won the prize. And the winning competition actually required so much computational power that Netflix preferred not to implement it. And this has been, quoted as a reason for a failure of this competition, because actually the winning algorithm could improve existing one, but it could not be implemented into production because too complex and not thought for being put into production, but just for scoring high enough for winning the competition, given its standards. But Netflix still used the most interesting insights and based on that algorithm, improve its existing one. And you can read on Wired an article which is very detailed, and I provide you the link about this winning solution and how it impacted the Netflix operations. So everything basically is ready for Kaggle to appear, because we have mentioned that we had a long tradition of competitive programming challenges, that also data science got at a certain point involved in competitions, and we had a very good example in the private sector given by Netflix, who activated so many researchers and passionate people in data analysis in their challenge. So Kaggle, how did it came to the light? Kaggle has been created thanks to Anthony Goldblum. And Anthony was Australian, an economist. And at that time, actually, he was working as an intern at The Economist. And he has given a task to write an article about crowdsourcing. We are about, the time is 2009, 2008, and crowdsourcing was kind of a big thing because there were books about it. People started to think, we could use the intelligence in crowds to achieve many things. and actually thinking of competitions as a crowdsourcing way of pulling together many intelligent people to solve problems motivated Anthony to start his startup, Kaggle. And so Kaggle actually appeared in February 2010, and after a while started proposing competitions. And actually stick. The community grew, a lot of competition appears. Myself, I noticed Kaggle finally in 2011 and started competing. And basically, when we arrive in 2017, we already have a community of over 1 million registered users. And now, just to give you an idea, the users registered are 8 million. And at that time, something very important happened in the history of Kaggle, because they were acquired by Google Alphabet. There has been that year the announcement by Fei-Fei Li, the chief scientist at Google, and since then Kaggle has been part of the Google family. If you don't know about Kaggle, I think the best way to tell you what Kaggle could achieve, apart from telling you how many users are involved, is retelling some very interesting stories. One of the first stories that actually struck me, because it was one of the first competitions I noticed it, is that Geoffrey Hinton, the godfather of deep learning, actually participated and won in a Kaggle competition. At that time, deep learning was a term completely unknown. Actually, he won with his team. At the time, I remember it was in a Canadian university, I think Vancouver University, and actually they won this competition by a large margin. And it basically kick-started the idea of using back again neural networks, because for a long time neural networks have been just forgotten. I remember when I started competing, we usually applied random forest and sun gradient boosting. And then Francois Chollet launched his deep learning package, Keras, during a competition. The Autogroup Product Classification Challenge. And I remember that at that time we were using very basic, one was lasagna, packages for creating neural networks for our predictions. And Keras appeared and immediately changed all the rules and became a successful product. And nowadays, it's incorporated into TensorFlow and is one of the spearhead products of AI from Google. And I cannot, of course, forget Tianqi Chen, who launched XGBoost. XGBoost is a gradient boosting implementation, which in respect of a classical gradient boosting that you could find in scikit-learn, at the time was speedier and even more accurate, because it was based on histograms in order to split the trees or its boosting machines. And that allowed, by giving, some randomization, some imprecision, much better inference at test time. And it was launched in a very famous competition, the Higgs Boson Machine Learning Challenge. But I could tell you more. There are other very cool stories. For example, Jeremy Aichin and Thomas de Godoy created a company, Datarobot, after meeting on Kaggle and participating to a few competitions. And Datarobot is one of the most important AutoML and data processing companies nowadays. And there are more and more machine learning software and packages being launched on Kaggle. And we also have some interesting stories of Kagglers like Giba, Gilberto Titeritz, who has been interviewed, for example, from Wired, and I have here the article. Here it is. So basically, here it is. So he has been interviewed, and the claim of the article was solve these data problems and watch job offers roll in, which actually launched and made everyone recognize Kaggle as a place where you could get spotted by headhunters or by companies and maybe launch successfully your career in data science. So getting back to the presentation, or even as myself, writing machine learning books, because this is not told everywhere, but actually I found my first occasion to write a book thanks to Kaggle. And actually, it's very interesting to listen to such very interesting achievements and top-notch success. But there are more common achievements that everyone, every day, can reach on Kaggle. And the previous achievements are very interesting to tell because they are anecdotal. They narrate how Kaggle has been important for the community of data scientists. But basically, what you can gain personally participating in Kaggle competition is learning, and learning by doing. That is learning practical data science. You gain a lot of field experience with data that maybe you don't work every day with. And you've been keeping updated on machine learning and deep learning, more efficient algorithms, because it's not easy to keep up with flow of papers and innovation we have in our sector. And it's also a place where you can create a network or experience and very motivated professionals. And that's something that it's incredibly important in your career. And of course, you can get known to companies and recruiters, and it can help you finding your next job, because maybe by participating in a competition, you can contact with someone who can introduce you to the company you want to work to. Very quickly, how Kaggle works, because maybe not everyone knows how it works. So the Kaggle community is very active and growing. As I mentioned, we have... So maybe someone open his or her microphone. Okay, I will just go on. I think everything's settled now. The Kaggle community is still active and growing. I mentioned previously that now it should be over 8 million active users. And what are doing the most of the people there? They are using the data that Kaggle is offering, most of them. They are using the notebooks, and we'll talk about notebooks that Kaggle offers. They are Jupyter-style notebooks, very similar to Colab. Or they complete a course, because in Kaggle there are many occasions to learn, and some are informal. For example, you learn from a competition, and this is one of the topics that I want to remark in this presentation of mine, but you can also learn from a micro course. There are courses on everything from basic to intermediate to help you learn the skills you need to compete and to do basically your data science work. And of course, many also submitted to a competition. That is, they participated into a data science competition and proposed their solution. We have different kinds of competitions, Kaggle. The most common are the featured and the research competition. Feature and research competition are one provided by private companies, and they just propose to you a problem of their interest to be solved. Sometimes they want to know from the top competitors, the ones that score the better in the competition, about how they code their solution and what kind of insights they got. And then you have the research one, which on the contrary are proposed by academic institutions, and they're often, the gate for publishing papers or being admitted as a speaker into conferences. Then we have a particular class of competitions, the masters ones. They are a little bit now, I think, not used anymore. They were closed feature competition, that is feature competition by invitation. They invited only a very selected number of Kaggle experts. Basically, they decided on the ranks. And annuals, which are competition that they repeat annually. In particular, I'm thinking of a March Madness competition, which was about sports and predicting results in basket university tournaments, but it was also one of the first examples of competitions based on a test set that has yet to be created. So it's quite interesting to test yourself on. And actually also the competition I will mention to you at the end of a presentation is similar to the March Madness because the test set is still to be created. Then we had the recruitment competition explicitly organized by companies in order to recruit the best performer in the competition, and then a series of competition that can help you to get started, as the name says, or playground, that is just test yourself without any pressure in Kaggle competitions. We also have analytics competition, which are quite qualitative. They require you to make a presentation or solve logically a problem, or often to prepare a notebook. And basically they are decided based on votes from your peers and on part on decision of a jury. And finally, the community, which are a recent innovation in Kaggle, which are competitions created by Kagglers themselves. That is, the community creates its own competition. And it's interesting because you can maybe test other Kagglers on problems that you want to solve, or you want to look for top-notch solutions. And also very interesting because you learn what implies creating a competition, from the anonymization of the data to, of course, avoiding any possible leakage inside your data. What is a leakage? Actually, a leakage is something that you cannot often mention in textbooks, but it often happens in real data science projects. You have a leakage when your training data provides some hint as some element of your test data. Sometimes the leakage is future leakage, that is, you have elements from the future leaking inside your training. For instance, if you are working in a stateless database where insertion and updates are done without keeping track of the time when they are done, probably you can find many fields that cannot be useful for predicting other fields. So, for instance, in fraud detection is very important when you're building your predictive features to find out any possible leakage, because there can be variables that are populated only in the case of fraud, or some are revealing something of the future. For example, what is happening to people who are actually detected as fraudsters. So leakage is something very important to be aware of in profession, and Kaggle can teach you a lot actually about that. Let's talk about where to start in a competition. If you never took part into any competition, let us see a page of a competition. You have to first to look at the topic of a competition, because motivation is crucial for your working efficiently and optimally in a competition itself. Why? Because it takes a lot of time and effort to get really involved in competition. And if a topic, the kind of data, the kind of problem, the company that has proposed the competition interests you, then you are more motivated. Always look at the topic. Don't pick just the first one that you see around. Then you have to check about the evaluation metric, because it's everything that decides a winning solution from a losing one. And the evaluation metric can tell you a lot about how to approach the data and what kind of algorithm to use in order to model the data the best. And of course, the timeline to know about how much time you have in the competition, and also a few deadlines that you have to keep into mind. For instance, sometimes you cannot join forces with other Kagglers, that is, for teams of competitors. until a certain date. So until a certain date is possible. After that date is not possible anymore. Then, of course, it's interesting to look at the prices. Some prices are really very interesting. And of course, there are some legal or competition requirements. Legal requirements are quite similar for competitions. You just have a look at them. Competition requirements may be different, actually, because sometimes you can use or not use, for instance, outside sources, such as supplemental data. Let's say that you're working with a problem regarding a recommender system. So the host, the sponsor of the competition, should make clear, for example, if you can use information that you can find on the web about the products, for example, that you have to recommend in this recommender system or not. And this has been quite a problem in some competition, because external data revealed to be a key factor for winning. After that, just check the data. So you just have to enlist the competition and try a little bit how it works. I didn't mention it here, but if you're new to Kaggle, probably you have to define your image on in the community. That is, to choose a name and to choose an image. When I started, actually, I decided just to put my name and my photo on it, but everyone is free to do whatever she or he wants. So you can use a pseudonym and you can use an avatar. The only constraint is that you have to use as verification your mobile telephone number. Why? Because sometimes there are restrictions on the number of tests that you can apply every day on your model, and having more tests can be advantageous, and so a few competitors just decided to open multiple accounts. Actually, you can have only one account. Remember, Kaggle always checks about unicity of accounts by looking at IP addresses and other revealing factors, such as, for example, correlation between the solutions. How classic competition work? So this is the classic approach that I initially started. You are given a train data set, which is represented here in the left lower part, and you have features in the train data and, of course, a target. And then you are given another separate data set, which is the test set. And you have to predict the target for that test set. So you prepare your model, you apply your model on the test set, and when you send your prediction to Kaggle, they are split into two parts. And actually, you don't know what parts are involved in the part which is called the public leaderboard, which is actually a ranking table where you can see the performance of all the competitors, of all the teams, and what part instead is given to the private leaderboard, which is another table which is hidden until the very end of the competition. At the end of the competition, the hidden part is revealed, and is actually that part that makes the rankings and decides who wins and who actually ranks lower in the competition itself. And you may wonder why, because it's very common if you have a test set to work in order to overfit. For instance, you can, for example, join the test data with your train data and try to figure out if they have the same distribution and leverage everything, for example, by transformation in order to overfit the test set. And this is something that, of course, the sponsor doesn't want you to do, because if you overfit the test set, probably your solution is not generalizable, and so is really not something of their interest. But the reason why there's this split, And in spite of this split, still, of course, there are ways to overfit the private one. And because actually you have the test data regarding the private part, and there are ways to figure out what parts is public and private. So recently they launched the code competitions, and in the code competition you actually have a test set, but the test set is limited only to the public leaderboard. Basically they ask you not just to produce a model on your computer, but to produce a model on their notebooks. And by having the code, everything in the notebooks, that allows Kaggle to replicate the prediction pipeline to a test set, which is actually hidden, completely hidden to you, and to produce, of course, its predictions, which will be used for the final rankings. I mentioned about the notebooks. So in code competitions, but in every competitions, you can rely on the resources, the computational resources that Kaggle provides to you. At the beginning, Kaggle basically was based on everyone's own computer. Everyone has to use their own machine or rent, in the cloud, a machine, and try to solve the problems there. But this caused kind of differences because sometimes it's quite relevant, the kind of machine that you have available, the computational time that you can access to. And basically, since in every competition, one of the key strategies for winning is trying as many possible solutions, algorithms, transformation of the data that you can. So experimenting as much as possible, having more powerful and larger number of machines could make the difference. So Kaggle decided to provide at least a baseline for everyone. And so their notebooks have different kinds. You have a CPU-based, GPU-based, or even TPU-based. They are just distinguishable by the accelerator they use. So for example, the GPUs use the NVIDIA Tesla P100. And as far as the TPU, you have the V38. And as far as CPU, basically you always have, cores available, usually the number of 4. But of course, the GPUs has a little bit less, just 2. And each type of accelerator have a quota. So for example, CPUs, they don't have any kind of limitation. You can just use as much as you want, but you are limited to 10 notebooks at a time running simultaneous. But GPUs and TPUs have a limitation to about 30 hours. And of course, there are running time limitations. So basically for CPU and GPU, you have 12 hours running time. When exceeding that, the notebook just stops, and 9 hours for TPU. You have some disk space where you can save all your results, and basically you can reuse everything you save inside the notebook, or you can download it or transfer to the Google Cloud, whatever you want. And actually that allows some integration because many Kagglers use different cloud solutions. Not only you can integrate with the Google Cloud, which is just one click in a menu of the Kaggle notebooks, but also we use Google Colab, and many of them also use other cloud solutions. Here an example of a Kaggle notebook. You can see basically it's very similar to a Jupyter notebook. You have cells and you can run your code there. But of course, you have on the right side examples of how it differs. For example, you can use multiple languages, you can use Python or R, and also you can, custom your environment, or also use different accelerator, as I mentioned, GPU or TPUs, for instance. Before I go on, another very important fact to remember is that all notebooks have access to internet. So basically you can scrape, download data, and connect with everything which is internet connected. In some competitions I mentioned, you are not allowed to use external resources, such as, for instance, data. So you have to disable that in that competitions. For neural networks pre-trained, therefore you have to rely on Kaggle resources, in particular about what you are going to talk now, to Kaggle datasets. Because Kaggle datasets are a space that Kaggle offers to you, where you can upload, for example, every file you have in your local drive. So it could be data, it could be the weights of a neural network, it could be even a package that you want to install in the Kaggle Notebook and that is not present. You can import data from a remote URL, you can import data from a GitHub repository and use other files from existing notebooks. I always been fascinated by concatenation of notebooks because many Kagglers, they just, since there's a limitation of 12 hours, previously it was even less, 9 hours, even for CPU and GPU. Basically, since they wanted to process large amounts of data, so we just split the data into batches and have different notebooks process a part of the batches, and then the results are passed by other notebooks, basically creating a pipeline of sequential notebooks until we arrive to the solution. And just a very quick mention about Kaggle datasets. Of course, you have some limitations in their usage. Basically, apart from the legal ones, that is, of course, you need to own the rights what you publish, especially if it is a public dataset that everyone can use and can see. You are limited to about 100 gigabytes for your private datasets, and you cannot create anything larger than 100 gigabytes, any single dataset. If you are using public data, you basically don't have any quota. So you can upload all the data you want with the only limitation that a Kaggle dataset cannot exceed a single 100 gigabytes totally. Here we have an example, and I just get back at this point to my browser. I just took this one, the wine quality dataset, because it's a dataset which is quite renowned. And you can see this Kaggle ESR has prepared images and explanations about the dataset. And not only describes about the variables, but provide a context to the dataset, and of course also the source. This is from the UCI machine learning repository, and you can find here actually much more support than there, because you can immediately just browse some code, exploring the data or building models, and sometimes you also have some discussion about the dataset itself. And you can find basically datasets about everything on Kaggle, which make it a very useful place for all your personal projects, which is very important because, as I mentioned before, Kaggle can be a place where you can be spotted by recruiters, by companies. So building interesting datasets connected with notebooks means building your own portfolio with all the tools that can make it shine. A portfolio that is immediately runnable, a portfolio that is easily explorable without too much problems, and that can really help about being spotted and your professional career. And as a last tool offered by Kaggle, there are discussions. Discussions are basically forums. You can find general forums and forums about each competition. Here, I just present the Ubiquan market prediction, which will be later the topic of our further discussion. And here you can see they just, have a discussion, and here you can find more the link, because this is a snapshot. And basically you can find information about from the company, so the Q&A about the data and the problem, and you can find more and more hints from the other competitors, because it's a usual and common standard to share ideas and to share information, even if we are in competition one with each other. And the only problem is that that's the reason why with Conrad, we wrote the Kaggle book, you cannot find always the same information in the discussions. So basically, in the discussions, every time you have to rely on the availability and on the idea of another competitor to post something useful to you. So it's very difficult. Of course, you can go and look in other competition for informations. And basically, when there's one competition, you always look for a similar or previous ones in order to find good information to instruct and give you directions, but that's not always possible. So having a good ground of knowledge is something that we reputed very important in order to boost more and more Kaggle participations. But in any case, in discussions, you can interact with other Kagglers, with other competitors, and you can find many ideas and many points. If you are struck in your modeling or your knowledge is covering your data, you can find many useful points to apply. Sometimes you will find you don't have enough time to test everything. And a mention has to be done also to tiers of rankings, because participating in Kaggle, is not just an experience of singular competitions, but all competitions are actually governed by the fact that each competition provides a ranking, but also points based on the rankings. And the rankings, of course, can increase your points. The higher you score in a competition, the more points you will get, but also the points are determined by your team size, because the larger the team, the less points each one gets, and the popularity, of course, of the competition itself. One underlooked aspect is also that how old the competition is changes the points you get. That means that when the competition completes, actually you get the full points, but as time passes, points get less and less, they decay. Why they decided so? Basically, I had experience of a time when, for instance, teams points were just split equally among all the people participating in the team. And also the points were always fixed and just remain in your history. But having fixed points means that if you're not an active Kaggle, an active data scientist in competitions, basically you always retain your points and they just stay fixed in a global ranking that they use to rank data scientists. So having a time decay means that if you're not active, you will soon disappear from the global leaderboard. Also, they use a different approach for teams. You see, they use a formula using the logarithm, and that allows actually, and also the root, actually that allows to, when you are teaming up, to distribute more points than you would get for the same rank, for the same competition if you played alone. Why? Because we wanted to incentivize team collaboration, and we wanted to incentivize solution proposed by multiple players, because they are usually better, usually more complex, they are usually more satisfying also for the sponsor of a competition. And the points translates into medals actually, because points get you certain types of medals, and then they translate into tiers, which is very interesting because each competitor on Kaggle is ranked based on a tier that explains about the achievements she or he has got along the road. And in any case, don't worry, if you achieve some results, they always stay on Kaggle. And even, the points that decay in time, if they allow you to reach a rank, they always stays. So for example, at the moment in competitions, I'm ranked at about 150 position, but once upon a time, I reached the 7th position. So actually, Kaggle just retained that information. And this is somehow overlooked, I mentioned to you before. So you could see that Kaggle is based on competition, on data, and you have many different people competing in order to create their solution and rank above the others. But you also have a lot of sharing tools. Notebooks, for instance, of course, are a tool, computational one that you can use on your own, but basically you can also make them public and share with everyone else. Also discussions help you to share, as well as datasets. Why? David Dono, a professor of statistics at the Stanford University, explained this as the common task framework, because not only Kaggle, I also mentioned before, Netflix competition, but also DARPA challenges showed that if you put together a certain number of ingredients in a competition, you can get a result which is actually an advance for the entire sector and for the problem at hand. So Professor Dono, what has found being the ingredients? So first of all, you need to have a dataset which is publicly available. In Kaggle, everyone can enlist in a competition. It's free and there is no limit. You can enter any competition you want. You are not barred from participating in anything. And of course, the related prediction tasks, because as you can get hold of the data, you can model it and you can propose your solution. No matter your solution is a top one or is a simple one, all the solutions are accepted and ranked. And then you need a set of competitors who share, of course, the same task. And Kaggle is the platform where actually you find competitions where everyone has the same task of performing the better based on the evaluation metric. And then you need a system for scoring. We had discussed about the leaderboards, that is the place where your modeling efforts, your prediction are scored, and that the leaderboards are partially known because you have a public one, we should reflect the private one, but it's different actually. So you cannot really overfit on it. And by having a system that scores exactly the participants, you actually are enabling everyone not only to be scored, but also to see what the others are doing. Because notably, every time in every Kaggle competition, when someone finds a breakthrough, an idea, it's just a matter of time before the other competitors just find the same idea and basically just reach that competitor or even overcome she or he. Why? Because everything, since is on the spotlight and since the leaderboard reveals advances from each team, just makes everything in this way clear, makes every team aware that something is happening and just push every team to look and experiment more. So by using competition, which is actually the secret source, together with open software and the ability to share, which is an enabler, an accelerator of good solutions, you basically have a system where at the end, your solution is always kind of a state-of-art solution. In fact, many solutions from Kaggle's top ones, especially to the research ones, have been translated into successful and interesting papers. So that's fantastic, right? But sometimes things go wrong. And what possible could go wrong? I mentioned leakage from the data. This is quite common, and it really depends sometimes on the difficulty that you have as an organizer, as a sponsor, to figure out that people can use the data in a different way than you just imagined. I remember an hackathon organized by Kaggle where there was a forecasting challenge. And at that time, as a forecasting practitioner, when I saw the data, I immediately ruled out using a certain type of variable. Why? Because I knew that it was something taboo in the real world, because it was something leakage, information from the future. But actually that didn't allow me to rank very well, very good on that competition. And people ranked better were people who could leverage that leakage. So this makes quite a difference, right? From projects I try to make it work in the real world, and a Kaggle competition. In the Kaggle competition, the focus is on the leaderboard, is on that result, or ranking your solution better than the other ones. And so you use everything. And this kind of optimization sometimes is kind of, not noticed by the sponsors. So we had the cases where ordering of examples hinted something about the test set, or where we had some leakage from the future, where just by combining or transforming variables, we could get an edge in the competition itself. And that's something that actually makes the competition goes wrong. It goes wrong from the point of view of a sponsor. It makes everything goes wrong, for example, from your point of view, because if you work very hard in making a very good solution and suddenly someone finds out a leakage, so a way to score better just by using some characteristic of the data, you will feel that you really work for nothing. But as it happens, actually it happened to me many times, actually is part of this kind of a framework. And so you shouldn't take it as, a non-success from your side. On the other hand, even in competition where you have leakages that, determine completely the final rankings of a competition itself, you still can find many interesting points and many interesting things to learn from the competition itself. So another possible things that could go wrong, I mentioned, is probing. So overfitting to a private test in some way, because you can, just test by multiple solutions how possibly the private test could be made of. Also just by, overfitting the public one, which is a very common occurrence, and then experiencing what is called a leaderboard shakeup. That means that everyone is just looking at the ranking made by the public test data. But the public test data is a little bit different from the private one. And so the models that perform so well on the public really don't perform in the same way on the private one. So it happens that when the competition closes and the rankings are revealed, the final ones, there's a shakeup, a completely different ranking that makes everyone unhappy. And that's another thing that could possibly go wrong and that could actually demotivate you a little bit. I have to confess, on the first ever competition I participated, I overfitted the public test set. I was, at the end of the competition, third in the rankings, and I was quite happy because it was my first competition and I already was ranking so high. Unfortunately, it was just the public test set, because the private one had a different story, and I just, lagged quite back in the rankings in the private one. But apart from the disappointment, I understood that it's very important in competitions as well as in, real world data science to really do something that works in the sense of generalization. And no matter the competition, just aims at having the highest rank possible on that board. Basically, that's a reflection of the fact that you cross-validated, you validated your model very well, and you did everything in order to be your model to be the most efficient and precise way of predicting. So that's very, very, very good lesson that I think you can learn every time you take a Kaggle competition, because I still can see a lot of competition where we have many shakeups and people just watching their rankings and not checking their cross-validation scores. And finally, we have private sharing, which is something that you could hear only on Kaggle. It means that some people play in a team, but they are not in a team. So they exchange freely information without, putting all the other competitors aware. As we said, sharing is very important, because when you share with the other competitors, you basically are, rising everything or the level of competition, because what you revealed becomes the base for everyone to start from. But if you are revealing that only to a small subsample of the competitors, maybe the people in your forum or your friends, actually that's something that spoils and actually deters the competition itself. So private sharing sometimes happens and sometimes can be quite disappointing. On the basis of all the things that could go wrong, some criticism has appeared, on Kaggle. So someone says that Kaggle provides a fast perception of what machine learning really is, since it is focused on the leaderboard dynamics, on the fact that you should rank. But as we said, actually, the competition has its own rule. It's a kind of mechanism, because the competition has a purpose, is a crowdsourcing in order to provide the sponsor with the best solution possible. So, of course, it's not the same when you're doing your own projects, but many characteristics, many procedures of what you're doing, of how you're facing data problems, solving them, building models is perfectly transferable to your real world projects. And getting skilled in cross-validation, in model optimization, in model ensembling can really boost your capability of doing great projects. And on the same, line, some say that Kaggle is just a game of hyperparameter optimization, and that's true. And sometimes that ensembling many models or just striving for a small increment in the results, it does make very little sense in real world. It could be true or not true. Actually, ensembling many models may be not feasible for example, having a very sane and safe modeling platform in the real world, because of course, the more models you ensemble, the more technical depth you are actually creating, because each models can have, different biases in respect of the data, and just putting too many together can result maybe in a good performing test sets, but in the long run may cost a lot to maintain and also require extra costs in order of maintenance and computational power. But learning how to ensemble sometimes is critical for solving certain problems. You cannot solve them otherwise. For example, if you have high variance in your predictions because of your data, because of a problem you're facing, you cannot find a better way than that, for example, assembling or cross-validating your predictions. That is, as you cross-validating, you just take your models and you use them also for predicting the test set, not just for predicting all your validation set, and having a measure, an honest measure to compare your solution in respect of others. And another criticism is that Kaggle is filled with inexperienced enthusiasts who are just trying everything under the sun in order to get a score. And basically, if you participate, there will be always someone else who has tried something that you didn't, and they will be scored and considered better than you. This is something that has long been running as an idea around Kaggle, and personally, I don't consider it something limiting. I participated to over 200 competitions, and I never posed myself a problem where I ranked in the leaderboard, because in some competition I could excel, in some others maybe I didn't spend too much time, and if someone just tries by chance something that works, it's okay. It doesn't mean that I don't know about how to do my work in data science, but simply that, I didn't experiment enough. By the way, most of the winners are constant in Kaggle, because when you get experience in experiments and you are very interested in participating, you can get consistent results. So basically, winners are not random. You can think about 2/3 are always the same people, but 1/3 is new people. And that's interesting because sometimes they are not inexperienced, and sometimes, most often, I have to say, they don't find their solution by chance, but because they had maybe an inner knowledge about the problem, or they're using something that no one has tried. For instance, some cutting-edge paper or some solution that no one else has ever tried before. So that's quite interesting, especially at the end, when everyone, if they want, reveal about their solution to know how they reached such, success, because it can enlighten you to a new way to solve a problem or to treat your data. On the contrary, someone says, actually, yes, we don't have just inexperienced. There's a lot of people who are paid to compete. Basically, we have a few companies that are sponsoring Kagglers competing, but I don't see it as a problem, because most of these Kagglers, they often share a lot, and it's okay. Yeah, of course, we have more time, more resources to compete, but this doesn't preclude you to doing a good job in your competition and learning. No one can prevent you to learn. And of course, we already treated that. Many say that as a consequence, competition solutions are too complicated and often too specific of a test set to be implemented. About the complexity, sometimes, okay, it's true. You cannot really replicate some solutions on your own problems, but as Netflix did, basically you can get insights and you can, get simplifications, distillation of that solution that can work perfectly in your field. And one last, remark is that Kaggle rankings do not have an automatic value beyond the Kaggle community. Actually, Kaggle rankings, your efforts on Kaggle and your results can influence, not in a direct, but more in an indirect way, your career as a data scientist, because they allow you to learn, to practice, to experiment, and to build an experience that on data and problems that maybe you don't have access to. And especially they help you to connect to other data scientists. Let's take an example before we close this presentation of mine, and we leave space to your questions. I recently took part in a competition from Ubiquant. It's a company, Ubiquant, dealing with investments. They are from Beijing in China, and they have a leading domestic quantitative hedge fund. And in the competition, they wanted to test if we could build a model to forecast a set of investments return rate. Of course, they provided a code competition framework because it was not possible, and I will soon tell you especially why, the reason, to use a fixed text set for this competition. And also they didn't want, us to use anything, related to the investment themselves. So some inside information, external one, or some special treatment of the data that could bring an advantage in respect of our participants. So the objective was to train and test your algorithm on historical prices, and given this API, special one, the final evaluation wouldn't be done at the end of the competition itself, but after 3 months on unseen data. So that's immediately, lighten up my interest, because it's the kind of competition where you actually build on data, you test on some other data, which is actually very near in time, but the real evaluation, the real fact that your model works or not is decided by data that no one has yet seen. And the data was quite massive. It was over 3 million examples. The features were about 300 and they were kind of hidden. You didn't know anything about them. So that posed a little bit of problems because in finance, if you know exactly what the features are, you can do a lot of feature engineering. And basically here you should go blind. In my experience, when you have such kind of situations, okay, you cannot learn directly from the features and feature engineering itself, but you can do actually some automated processing. For instance, many algorithms, they find difficult to figure out ratios between features. So if, of course, you know the name of features, you can, make business-minded ratios that could be useful for your model. And here you just bandly just check what ratios work, but you can, just process automatically and just retain by selection in your model what works from what doesn't work. So it's a little bit different kind of approach from real world projects, but you are using the same kind of processing, the same kind of tricks. You cannot use actually business knowledge directly, but some can really help you to figure out how to build a good model. And interesting, you had a certain number of assets. They were 3,500 about, and they were expressed in a range, which already hinted that in the test set, you had probably different assets, at least a set from the train set. So basically, the sponsor was trying not only to project the model into the future and non-future, but also into unknown examples in the sense of different assets. And basically, it happened a leakage during the competition because one participant, in some way, probably just looking at the data, I suspect that the output, so the target itself, figure out what the assets were. And by figuring that out, actually, you can provide extra information. For instance, since you had to figure out the returns of each of the assets, the sector of a provenance, the provenance sector, could really make the difference because different sectors have different baseline returns. And if a sector is not enclosed into the anonymized feature that you are using, this is really a plus. So the sponsor just kept calm and said, it's okay. Now you just scrape this data, you found a way to match the assets, but you don't know the test set because the test set is yet to come in 3 months. And in 3 months, we can even decide to use all new assets in order to evaluate, right? So basically, there was a leakage, but the leakage, given the fact that, the problem is flexible, it's still probably to be completely defined, allowed your models to be built without any fear that anyone can have an unfair advantage. And we use train steps in the number of 1,200, and you didn't know exactly what time steps were. It could be trading days, it could be portion of days, you really didn't know. And the evaluation, very interesting. They took each day and they just normalized the returns. And basically, you have to figure out a prediction of that normalized by day returns and perform the best on the mean of a person correlation coefficient for each time d. That is, we make the correlation of your prediction separated by each day, and then we make the mean. And what could I get personally from this competition since I really work in finance? Well, quite a very interesting, first of all, experience in EDA, because I could just try to figure out what was happening, and that gave me a lot of ideas. For example, notice it that the number of assets by time units was growing. And sometimes they use a very small number of assets, meaning that probably the assets were dynamically decided based on the trading strategy, for example. And that also by analyzing how the spread, even if it were normalized returns, how the spread and the mean of the returns changed a long time, meant, was quite informative, because I could figure out that there was portion of times that were qualitatively different for sure in the respects of the outcome from others, because you had more, for example, different means, mean return, and of course more variability. And of course, I already mentioned that working without a leaderboard is kind of a challenge, because you have everything in the future. And that led to using sophisticated CV strategies. And Irun Zhang, a competitor, just shared this idea about the combinatorial per group k-fold cross-validation, which is something actually I read of in a manual, Advances in Financial Machine Learning by Marcos Lopez de Prado, but I never had the occasion to use in reality, because my work is a little bit different from what is done in a hedge fund or in the trading desk. So basically, in this explanation by Irun, he provided the code and some ideas, and I could have a first, occasion to myself try this kind of CV. Now, you know that CV is very important, and basically when your observations are IID, but is identically and independently distributed, you can basically just take your data, split it into folds, and use the folds for repeated training and tests in the way that you can get a probabilistic estimation of the performance of your model on your data. But that doesn't work so well for time series. Why? Because time series, they have serial correlation of your observations. So basically, you cannot really put together past and future and obtain a good results, because you can have leakage of information, and especially the serial autocorrelation can really pose a serious problem. But in finance, is not sure and safe to tell that if you take a series of information and you build your model on that series, and then you try to forecast a successive subsequent period, you have seen enough information to be able to figure out exactly the dynamics of a financial phenomenon that you are trying to model in. So the idea of this combinatorial per group k-fold is to use folds of the past and the future all together. Why? Because some structures, some patterns can be revealed only in respect of certain parts of the series that you are analyzing. So you cannot just say, I use the first 80% for training and the last 20% for testing. You could mix like you would do in a k-fold, but with some caveats. That means with some modification to your data. First of all is combinatorial. It means that once you decided how many splits you want to use in terms of total and how many splits you want to use for test, in this example, they are 2, and so they are different, and they can be quite separated in time. You can make all the possible combinations with folds, which are quite more than the folds you could get, for example, just doing a k-fold with the same number of splits. And another important aspect of this approach is that you determine purging observation and embargoing observations. And that can help, maintain the separation between past and future, and allow you to model each time an effective model. In the case of a competition, it means, for instance, that here you have 15 possible combinations given the 6 splits and 2 test sets. And you can use these 15 models, and each one able to recognize certain kind of patterns, and then just average the prediction together and have a more solid prediction. And what are the interventions that you make in order to allow even mixing present and past splits to work well together? First of all, you purge everything in terms of observations that have, common grounds in both train and test. In finance, this happens when you are analyzing, for example, intraday data, but you are using some information about the opening, which is not, already closed. So you can have some examples that have exactly, the same time span, of efficacy as the test set. So you basically just say, I just want to cut them, and you just remove them. And you can see here the representation shows some gaps, and some are larger and some are smaller. Basically, when you purge, you are just cutting in the same way to the head and the tail of your folds between train and testing ones. And what are you doing? Since we are not knowing this competition about the representation of the time ADs, you just decide that you experiment that maybe they represent a quarter of a day, and just purge enough information to allow that you don't have, any leakage based on time. And then you can embargo, that is, you can cut furthermore in the testing folds, the last part, in order to avoid that you can have, when you are just training on the next continuous, fold using for train, autocorrelation between the 2 folds. And in this way, you can, just mix past and future together and still obtain a general model that can generalize quite well. And this is really, it's been a very good occasion for me to test this. And then I found very interesting the optimization evaluation metric and all the discussion around it. So here Martin just pointed out that using person correlation directly in the optimization process, for example, of a neural network was kind of risky because of derivative that you can see here in the graph related to at a different, situation of correlations of your examples. So when your examples are perfectly correlated or not correlated at all, you don't have so much gradients. So it means your model, if you're using a neural network, especially, doesn't change too much, doesn't react to the examples that actually are really not well represented. Here he made a simplification because in correlation you also have the negative side, and in this case, having something negative means really making something wrong. But in any case, the discourse is that if you just optimize directly Pearson correlation your models, you can get a training which is quite erratic and also sometimes suboptimal. So the idea is to use Pearson correlation, for example, as a stopping metric, but not as an optimization one, and to rely on other solutions, for example, mean square errors, and that should work better. Or, as I experiment myself, to rely on Pearson correlation, but since at this point there could be some problems with gradients, to try to, constrain gradients into a certain range and to use different initializations, because since the training could be quite erratic, you could have performing models and non-performing models. So by different initialization, you can try the same set of data and the same model and obtain different results. And basically, you should just keep the results that perform better on the validation side. It also gave me a great opportunity to explore different neural network architectures. So I found out that, for example, we use a lot of conv one-dimensional, convolutional one-dimensionals for time series and simple dense layers, but with activation which work quite well. And also open to a lot of experimentation with NAS. And here I conclude my presentation and just leave to you at this point the drawing of the free book and all the questions that you have.
Okay. Yeah, thanks, Luca, for the nice presentation and the nice intro to Kaggle. I'll think we can, yeah, as you said, move on to the quiz. Let me share the screen. Here. So as everybody can like join the Slido with the QR code or the link, and then we can start. Yes, so please join the quiz. Oh, nice. The first ones are getting in. All right. Okay, we're close. Let's wait until like maybe 30 are in, so then we can start. Okay, guys, hurry up. Like, let's wait for another 20 seconds and then we'll start. All right. Well, then I think that's it. Then we start the quiz with the first question. Like, when Kaggle has been announced becoming part of the Google alphabet? So. All right, final one. All right, let's see the response. 2017. Most of you typed in, and that's correct. Okay, let's go quick here. Next question. When, I hope I spelled it right, Tianqi Chen has launched on Kaggle? Okay, 19, and 20. All right, most of you guessed the XGBoost package, and which is correct. Cool. Third question. What competition grandmaster has been interviewed by Wired? All right. 3, 2, 1. All right. Gilberto Titerix is the first guess, and it's right. So final question for today. How many CPU cores do you have available on Kaggle notebooks when you are using a TPU hardware accelerator? Okay. 16 already answered. 18, 19, and 20. Nice. So most of you think it's there are 4 cores, and that's correct. So let's see the results. And the winner is Amin. Congratulations. You're receiving the ebook from Luca, the Kaggle ebook. What we need is your your name and your email address, which you can send via to our DSC email, right? And we'll send you the PDF. Cool. Right.
To which email should I send it?
To our general DSC email, right?
Yes, I just sent the email in the chat.
Okay, cool.
Okay, thanks a lot.
Compliments again. I mean,
cool.
Congrats.
Congratulations. Yes. And you're the quickest one. Like 29 seconds is pretty quick. Cool. Let's go to the questions. Let's skim over them. If you still have time, Luca.
Yes, I have. I'm very happy. Sorry, maybe my presentation was a little bit too long, but I hope that was interesting for all of you. And I really hope it conveyed the idea that Kaggle is competition, but is also professional and personal growth. So,
yeah, that's really cool. I think over the presentation, you could see that you're really passionate about Kaggle. So I think you're the perfect person for this event.
So 11 years.
Yeah, that's cool. All right, then let's start with the first question, like the top voted one. Like, how different is your actual job as a data scientist from Kaggle competitions?
Well, there are similarities. Of course, it's different. As I mentioned, a competition is a competition, and you are ranked based on a leaderboard, on evaluation metrics. Is everything very clear? So first of all, I work modeling, so it's very similar to a competition. And many ideas I have found out that taken from competition, they work perfectly in my working settings, and they boost actually many results. But on the other hand, I also have some differences that I have to keep into mind. I overly mentioned about production, because when you create something as a data scientist, one day or the other, if it works, it should be put into production. It means putting the API into something that can be used by everyone. And production means scalable, maintainable, means something that actually can hold a long time and can be renewed and refreshed, which is quite different from competition. Because competition, you have to perform on a precise test set, on a precise situation. So that's different. Another thing is different is the metrics. You have one metric in the competition. I often do have many metrics to keep into eye, and many are business ones, and many are not under my control.
Mhm.
So there are differences, similarities. The most important thing is that you can take a lot of things you learn on Kaggle on your work, and they are successful. But of course, it's not enough.
Nice. That's good points. Cool. Okay, that's this question. Like the next question, how much time do you spend on average on a competition?
Okay, it really depends. It depends on the time I have. If I have a lot of time, I can spend all the time I have on the competition, but usually I don't have so much time. So I spend very little. And so sometimes my results recently are not so, skyrocketing. I remember that when I was, quite involved, I could spend even 4 or 5 hours a day on a competition. What I want to tell you is, first of all, take a competition as early as possible. So you have a lot of time to study, to see how the competition progresses, and to devote cumulatively more time on the competition itself. Then just decide how much time you want to spend on it. It's not obligatory you spend 1 hour, you spend 24 hours. No, you decide how much. The one thing is very important is that this is quite strange. Maybe it works only for me. Taking a competition, not participating into it, and looking at it at the end doesn't bring any advantage to me. I really have to get involved. So even if it is just 1 hour a day, half an hour a day, I have to work on the competition in order, in the end, to understand everything of that competition, also through the boards and description of our competitors.
Cool. All right. I'm going more quickly over the
yes,
questions.
The slide will be shared.
Yeah.
I need suggestion how to find good teammates within Kaggle. It's very difficult. Try and error. I tell you, I had once an experience with a teammate who made us disqualified from the competition. We were quite high, I think the top 30, results. And actually, one people we took in the team did something wrong, and they disqualify us. Also, you can find people more or less collaborative. I think it's something quite reflective of what happens in real life. Just try, and you just you go out on Kaggle and just post, make a post on the discussion and say, I want to make a team, I have these terms, and see whoever answers. Just try. In the end, you will find some people you can rely on, and you can make very good friendships with your teammates, really.
Cool. In this regard, like, do you communicate mostly over Kaggle, or like, is there any like most famous channels like where like top Kagglers communicate?
Actually, we use, for example, Slack or Discord. You can use whatever you feel like,
Okay, cool.
I even use email. It's all up to you, and it also helps, in team building, because I had experience, teams, spread across, all time zones in the world. So don't limit yourself. Try. Sometimes you won't, be perfect. You won't be happy, but sometimes you can really meet very incredible people in your journey.
Cool. Yeah, what are more important in the competition, feature engineering or building great models?
I would say experimenting. Actually, feature engineering was a key factor in the past when the competition were more tabular type. So we were based on very specific contexts where if you had an idea of how business or how the context worked, you could create features that made the difference. Nowadays is not really true, because basically you work with text, images. Most of the competitions, they don't require you to feature engineering, but use the right architecture to experiment, to test papers, and also to find something innovative and be creative. So I would say experimenting and being creative now is more determinant.
Cool. All right. Which are your preferred frameworks for standard prediction competitions?
I work a lot with TensorFlow, actually, and with LightGBM. But basically, you can use anything that works. A lot of competitors use PyTorch because it's more kind of flexible, but I think it depends on how much you are accustomed with each framework. One thing is very important to keep into mind. You have to be fast, to be quick. So just rely on what you know more, unless you use the competition for learning. Again, I was a strong user of R at the beginning of Kaggle, but I realized that R has some limitation. So I used some competition to learn how to program, in Python, and how to use effectively scikit-learn. So it is up to you. If you want to perform, use what you know and works better for you. If you want to learn, try everything you want to learn because it's the right playground for you.
All right, the next question. How would you estimate the time effort for a Kaggle competition if you want to achieve a good result?
It's very difficult to make such an estimate. I guess try to work it at least every day. And every day saying, I want to make an improvement to what I've done before.
Okay. I think that, yeah, that sounds reasonable. It also depends on like what level you are currently in the on the technical on the theoretical part.
Yes, I have to say something about my work experience. In a position, the team leaders said, Luca, we really appreciate your Kaggle experience because for the problems we are dealing with, you already have a feeling about, what could work or what could not work. So really spending a lot of time on Kaggle can really expand your knowledge of data and problems. But as I said, it really depends on the time you want to spend on it.
Okay, cool. I think the next two questions are already kind of answered. Like the next question is more about like how to approach like to train and validate data images, and next one is like which programming languages to use. But I think you said it already, like which works best for you and which type of like framework and languages you know best works best in the start, right? Yeah, cool. All right.
I see something about cross-validation that would require another, meeting probably. So
yeah,
it really depends on the situation with data and the problem.
Yeah, like see Kaggle competition in real-time problem in your experience.
I think you already see something like that. So we have some, common aspects and some different ones. The common aspects is that many of the things that you can learn can be applied to your problems. And you actually don't know what will be useful for you or not in the future. But everything that, I've been in contact in Kaggle, one way or another way, sooner or later, it has been useful to me. So I think that this is something that can be extended to everyone's experience. Yes, I do read research papers.
I think, yeah. You also mentioned it in the presentation, like some people have like used cutting edge papers for like results.
Yes.
And,
yeah, always on the spot on GitHub, on Hugging Face about, new architectures, new trained, neural networks on different sets of data. You have to keep an eye on many different, directions. It's difficult to say something, precise about, you should do this or do that. Papers are a very, very important source of cutting edge solutions.
Especially like the theory keeps growing, and the researchers are like pretty active. So yeah, that's
yes.
Cool.
There's always something new.
All right. Next question: how to choose a suitable competition on Kaggle?
Based on your interests, as I said, because you have to spend doing it seriously means a lot of efforts and time. It should be something that interests you. Just anecdotically, I discovered Kaggle, but it took 3 months for me to start. Why? Because I didn't want to disfigure, so to make a a best show of myself, which actually I made in my first competition, as I told. And the reason why I entered that competition was about natural language processing and Twitter, and they interested me at that time. So I entered because of interest, and I got inside the competition because the topic was something I found interesting. So do the same.
Okay, cool. Next one is kind of like a group question. Like if you participate as a group, and how should you divide tasks usually in between the group?
That's a little bit difficult to say because it really depends on the competition. Generally, if you can produce diverse solution and then ensemble together, you get a better result. So in a group, basically it works very well at the beginning to have divergent thinking. But if we meet, we decide we have to produce something, everyone has to do a certain amount of submission and models, and then we start working and we separate. Because by being separate means everyone is looking in a different way and there's no group thinking. In the later stages, we all find again together to share insights, to share ideas, and to try to put all the work of everyone together. Basically, I would say, try to understand the strong points of everyone in the team and try to just assign tasks based on the strong points, then on the weak ones, and try to make the team diverge at the beginning. Because the more things and different you try, and then you ensemble or you learn from, the better.
Okay, cool. All right, final 3 questions. The next question is about like the discrepancy about like low amount of data in the training data and like a large data set at the test data, like how you can tackle these kind of situations.
Basically, models, vary in the way they represent the data. And we explicit that in bias and variance usually. If you have a low amount of training data, you cannot rely too much on models which have a high variance. Why? Because they will tend to learn everything inside the trained data, even the noise, and that will result in a bad generalization. So you have to first rely on simpler models that can represent in a simpler way the data that have more bias. I will start with very simple models like linear regression, logistic regression, so the generalized linear models. Then try the support vector machines too. They are very good when you have low amounts of data because actually, given their complexity, they are quite scalable for the problem in itself. The prediction is another topic, of course, but you have also now implementation by NVIDIA in GPUs, so they can even work then in the test with very large amounts of data, and they can help you to catch only the relevant information if you have very little data. So my suggestion is start very easy, use linear model, maybe just main effects, no interactions, and then try support vector machines. Another trick is to use subsampling and bootstrapping in order to enhance your data. But actually, the fact that the data is little, it remains little. So what I say at the beginning, you have to, rely more on biased models, but on, variance ones. It's something that you cannot overcome. There's no way.
Okay. Last 2 questions. Is it smarter to compete in smaller competitions with a lower price pool, or in a large competition with also more competitors?
It depends on your purposes. In smaller competition, you can have more interaction and be more free to make friends, share, and know a lot of people. In larger competition, okay, the struggle will be very intense. Everyone wants to rank higher, but probably you have more chance to learn more interesting things. If a competition is small, it is because maybe the topic is not so interesting or too niche, and maybe your learning could be more limited on that point of view. So it's a trade-off between knowledge and, you know, connection. You decide what is more important for you, and you go accordingly.
Cool. Okay, final question of the day. I think a nice one. What's your favorite regression loss metric?
It really depends on the problem.
Maybe like just one, like for which you use most, just for the sake of the question.
Mean square errors.
Okay.
Or
Cool.
root mean square errors. Basically,
Okay.
it really depends on the purpose. So it's not the point of, you know, a metric being favorite or less. It really depends on what your model is going to work to do. And based on the problem it has to solve, especially in real life projects, you have to determine what could be most suitable metric. So for example, if you use, you know, the mean square error, clearly larger errors will become more important for your model because we are square, right? So basically, if, you know, actually your problem would be, you know, to perform in an average way, maybe you should use like the absolute mean average error, for example. So use something different. But I say it really depends on the application. That determines the kind of error that you can accept or not accept.
Okay.
And then you decide your metric.
Nice. Sounds great. That was a final question. Thanks everybody for still bearing with us. I want to hand over to Leander, who will like talk about like our future events and like to sum up everything. And yeah, thank you guys.
Thank you a lot for having me as a guest. It was a pleasure, and I really enjoy being with you all. And good luck for all your competitions and real world projects.
Great, thanks a lot for the great talk. Actually, personally, I know Kaggle for quite a long time, but haven't tried out yet. So this like really motivates me to get started with that. And I know it's quite late, but I still have some exciting upcoming events to share with you, but I will keep it short. So I hope you can see my screen now. So first one, next Thursday, 12th of May, starting at 6 p.m., we will have industry level machine learning talk with Morgan from Weights and Bias. And so we will explore how to make your machine learning research reproducible. And also we will have a 45 minutes Kaggle-based machine learning competition with the chance to win some swags from the company. So I believe this is also a great chance to try out Kaggle, maybe as your first start. And this event is also collaboratively organized by us, these three GDSCs. So feel free to register at your corresponding community. And I think if you are based in Zurich, you could even attend this event in person. And another one is probably more relevant for our members at GDSC Munich. So we are going to have our first on-site event since COVID next week, Tuesday. And it's in collaboration with Manage and More. We will have three high-profile panelists and to share how like their entrepreneurship journey and how Manage and More helped them to become a founder. This event takes place in the Google office, right in the middle of Munich, so really exciting. But unfortunately, the number of seats is really limited, and I think there's no in-person tickets left anymore. But feel free to join the waitlist in case someone cancels their reservation. And other than that, you could also watch the live stream. So that's it. Thank you so much for joining us today, and thank you, Luca, for your awesome talk and the prizes you provide. And yeah, wish you all have a nice evening and hope to see you next time.
You too. Thank you a lot indeed. It's been a pleasure.
Thank you, everyone. Thank you, Luca.
Bye-bye.
Bye-bye.